One question we've been getting and that we're really interested to know the answer to is how can wave add value to our energy systems? How can wave provide system benefits in addition to wind and solar generation and other renewables? For this, we've looked at a case study in the north of Scotland. So we've looked at wave, wind and solar profiles and how complementary they can be up in the north of Scotland. We've taken hourly profiles and tried to look at where wave can be available at times of low wind and solar, and vice versa as well if we have a dip in wave resource, if there can be wind and solar profiles that match. The case study looks at a cost-optimal combination, so we have costs, capital costs and operational costs for different renewable energies and also for storage. And what we're looking at is to see what is the best combination of wave, wind, solar and batteries to meet a 24/7 clean energy load, essentially. So a completely flat load throughout the year met by a very high proportion of renewable energy. The results of these cost-optimal mixes are actually really interesting. So wave does get picked up as part of our cost-optimal mix. Even though wave can be more expensive than wind and solar, it can be 2 or 3 times the price of other renewables, wave is still picked up and is within our cost-optimal solution. So if we have a scenario with wave and one without, we actually see our scenario with wave has a lower installed capacity in total. We don't have to over-install as much wind and solar or use as much batteries. We also see that overall we use batteries a lot less if we have a more varied renewable mix that includes wave. And we see that the costs reduce. The system cost reduces when we have wave in our optimal mix, even though wave itself can be a bit more expensive. So our base case results showed 10 to 20% wave in our cost optimal scenario. If we include some constraints where we look at profiles for wind and solar and we look at the existing generation in the north of Scotland, we say that perhaps only a certain amount might be consented in the future. What we see for scenarios where we include some constraints to limit the amount of onshore renewables, then wave is picked up even more in the energy mix. So it can be picked up to 60 or 70% in combination with offshore wind and batteries and other renewable energies. So these results have been a really interesting way of us investigating the system value of wave, how it can add to these power systems. We see as we move into the future, as wave becomes more cost competitive, there's an even higher value of wave as part of a cost optimal mix in our scenarios. We also see that these results can be shared all around the world as well. They're fairly consistent when we look at a case in Portugal or Australia or the west coast of the US. And that's a really interesting finding that even with slightly different profiles, different weather patterns, just having a more diverse renewable energy mix, which includes wave, which can be offset from other renewables, really adds value to our energy systems.